Section 2.4 is continuity. Think of a graph of a function. Think of a parabola. If you can trace the graph without lifting your pencil, then we say that the graph is continuous. In general, polynomials are always continuous because polynomials, their domain is all real numbers. Rational functions, they are continuous except where the bottom equals 0. Remember that for rational functions, the bottom equals 0 means that we have either wholes or vertical asymptotes. Think of sine and cosine, that's this shape here. So that is always continuous. You can trace the graph without lifting your pencil. For tangent, cotangent, secant, cosecant, those graphs are discontinuous at the vertical asymptotes. Continuity at a point, it says here, we have a function f of x. It is continuous at a point x equals a if and only if the following conditions satisfied. So number one, it says f of a is defined. So f of f of 3, f of 4, do we get a y value? If we do, then we go to the next condition. The next condition, it says the limit as we approach x equals a, it says. Then we go to the next condition. Are these two matching? Are these two the same number? If they are, then we say the function is continuous at that point. The moment one of those conditions is not satisfied, then you stop there and you say, oh, it's not continuous at that point. And here I gave you example. So I gave you this graph, y equals f of x. I gave you an example of how you justify continuity. So for example, it says the function is continuous at x equals -2. So look, this is x equals -2. Very first thing, first condition, we check for f of -2. F of -2 is 0. So that is satisfied. We get a number. Then we check the next condition. The next condition is the limit of the function as x approaches -2 is, so as we approach -2 from the left and from the right, the function is approaching 0. So that's satisfied. Then you check, are those matching numbers? Is this and this the same numbers? It's satisfied, so they're matching numbers, so we say the function is continuous. Since the limit as x approaches -2 equals to f of -2. F of x is not continuous at x equals -1. So this is x equals -1. First, we check what is f of -1. F of -1 is, you look for the closed circle. The closed circle is at 3. But it's defined, so this checks. Now we check the limit of the function as x approaches -1. So as we approach -1 from the left side, the graph is approaching 3. As we approach -1 from the right side, the graph is approaching 1. So it's approaching different values. So those values don't match. We say the limit itself does not exist. So at this point, we stop. The second condition is not satisfied, so that's where we stop and we say the function is not continuous since the limit does not exist. F of x is not continuous at x equals 0. So at x equals 0, notice how from the left side, the function is going to infinity. So we have some sort of vertical asymptote at x equals 0. And then from the right side, notice how we have an open circle. So in this case, if you try to find f of 0, this is undefined. This is undefined because we don't have any closed circles at x equals 0. So you stop there. You stop there and you say the function is not continuous since f of 0 is undefined. The first condition is not satisfied. Let's do the last one. F of x is continuous at x equals 2. So let's go to x equals 2. First, we look for f of 2. So in this case, we just have to approximate it. It's about 3.5. So we say f of 2 is 3.5. Then we want to find the limit of the function as x approaches 2. And in this case, as we approach 2 from the left and from the right, the graph is approaching 3.5. These two numbers match, so we say the function is continuous at x equals 2 since the limit equals f of 2. And so that will be our justification at x equals 2. Now, if we go to the homework, let's see. This one here, it says, use the graph below to determine the limits. The limit of the function as x approaches 2 from the left side. So as we approach 2 from this side, the graph is approaching, so this is the graph is approaching 3. The limit of the function as x approaches 2 from the right. So now, if I'm coming from the right, let's see what the graph is doing. The graph is approaching 3 as well. So the limit of the function as x approaches 2. So just 2 itself, so are these two matching? If they're matching, then the limit is also 3. And now it's asking, what is f of 2? F of 2 is 2. So this is 2. The function f of x is or is not continuous at x equals 2. We say the function is not continuous at x equals 2 since these two values are not matching. So in this case, I would say this is 3, this is 3, this is 3. This was a 2, and the function is not continuous at x equals 2 because the limit and f of 2 are not matching. Question number 3. The graph below is the function f of x. Determine which of the following rules for continuity it's not satisfied at x equals 2. So let's start with the first one. The first one, we're looking for f of 2. So remember, 1, we're looking for f of 2. F of 2 is over here. F of 2 is 4. Well, this is good because it's defined, so that's good. Number 2, we're looking for the limit of the function as x approaches 2. The limit is -3. That exists, so this is good. Now, the last condition is, are these two matching? These two numbers are not matching, so at this point we say that the limit of the function as x approaches 2 does not equal to f of 2. And so this doesn't satisfy. This is question number 8. Let's do 1 or 2 rows so that we can see how to answer this one. This entire row is about -7. So we're looking for f of -7, the limit of the function as x approaches -7 from the left, as x approaches -7 from the right, and as x approaches -7. -7, it's this here. So we have an asymptote, a vertical asymptote. Because of that, we say D and E. This is D and E. The limit of the function as x approaches -7 from the left side. So as we move in this direction, as we approach -7, look at the graph. The graph is going this way. So it's going to -infinity. The limit of the function as x approaches -7 from the right side. So as we come this way, the function is going down to -infinity. Now, the limit itself, as x approaches -7, so since these two are matching, the limit is -infinity. The function is going to -infinity from both sides. Is f of x continuous at x equals -7? No. The moment you have a D and E, remember, this is the first condition, this is the second condition, and the third condition is, are these two matching? These two have to match. The moment you get undefined for the first condition, automatically that makes it not continuous. So let's see, for this one, For this one, we had DNE, negative infinity, negative infinity, negative infinity, and okay. So here we have to provide an explanation. So the first condition does not satisfy. So let's focus on this one. This will be no, the y value is not defined. Let's do a different one. Let's do this one when x is 13. So that will be over here. F of 13, that will be this closed circle, which is at 3. The limit of the function as it approaches 13 from the left side. So as we come this way, the graph is approaching 2. So that's a 2. The limit of the function as it approaches 13 from the right side. So as we approach 13 from this side, the graph is approaching, the function is approaching 2. The limit of the function as it approaches 13, since these two numbers are matching, the limit is 2. And then if this and this are matching, then we say the function is continuous. In this case, they're not matching, so we say it's not continuous. So this was a 3, 2, 2, 2. And in this case, it's about this and this not being the same. No, the limit does not exist. The limit exists. No, the y value does not equal to the limit. That's true. And the other one says, no, the y value is not defined. The y value is defined. So this is the right answer. And again, I didn't do the other ones. Let's see how we got them correct.